and boring. Okay, next thing, and then we're going to actually start doing some problems, okay? One more thing I need to establish here is some notation. Okay. A sequence, right? A sub n can be written in, and this is the notation we will use for a sub n equals something, all right? What did I write earlier? N squared, right? So what I'm going to do is I'm going to use that example, all right? I'm going to use n squared. That is notation that clearly establishes the sequence, all right? If I wrote that down, everyone should be able to list out the numbers. Agree? You could? Okay, another way I could write this, another way that you might see this is these braces I draw, sometimes they just go crazy. You'll have the same problem, I'm sure. Okay? So that right there is the same as that. Okay? So think about it. What's happening here is you're saying, all right, you're going to have a list of numbers, right? And how do you generate this list? By using this formula. All right? Yes or no? Yes. Yeah? You have to start at 1, then 2. So you see, with sequences, you have to understand that you're going to start at 1, then 2, then 3, then 4, then 5. Like, you have to understand that. It's never going to be anything different than 1, 2, 3, 4, 5. Well, later on, we're going to start at 0, but don't worry about that. Yes?
So does n represent, like, because you said a sequence is when it's a natural number, like for now, it's where it's when you get a natural number and the output's a real number. So is n saying you're just squaring the natural numbers, like 1, 2, 3, 4, 5?
I'm giving you this is a specific example, all right? I'm giving you a specific example right here of a sequence. The sequence, I'm defining it to be a sub n is equal to n squared. So another way you could write that would be this way. I'm not sure I understand your question.
Because n is just saying a number.
N is a natural number.
Okay.
It's got to be a natural number, starting with 1, 2.
The double cross, the double line in?
No. We just need to know that double line n is what we're going to plug in here. See, we're using n instead of x. But we need to understand that those n's that we plug in are going to start with 1, then 2, then 3, then 4. Here's another notation for the same thing.
Are we ever going to be given the sequence and have to make the formula?
That's exactly what we're going to do. The question was, am I ever going to write out the list of numbers and ask you for the formula? Yes, absolutely. And that's a skill that you're going to develop, and you're either going to sink or swim with it. I mean, it's one of those things where when you see it, it's going to be light bulb, you can get it, or you can't. I mean, you'll see. It's like a puzzle, okay? It'll be like a puzzle. But first, just trying to establish all the notation first. Okay, so do you see this one right here? I did it. Sorry. 1. These all mean the same thing. If someone writes that, you need to know, okay, the first thing I'm going to do is plug in 1, and then I'm plugging 2, then 3, then 4. Someone writes that, you need to understand that means the same thing. Start with 1, then 2, then 3, then 4. Someone writes this, then of course they're telling you n is going to start at 1, right? And end where? In infinity. So it's like a starting and ending point. Now what if I replace that symbol right there with a 4? I'm going to stop at 4, and then the sequence would be finite, right? If I replace that with a 4, then that's it right there, right? So you see, this notation allows us to actually write down a condensed version of a finite sequence by using this notation. But if you don't put this here, if you don't put this, right, it's implied that it starts in 1 and ends at infinity. Yes?
So how many examples did you put in your bracket before you stop and show it?
How many do I need to show here?
Before you decide do that.
If somebody gives you the formula, you can just write out the first couple. It doesn't matter in the ... If you had the formula, you know you could generate each of the others. Yeah? Okay. What else? I think that's good for now. Yeah, I think we're ready. All right. So our challenge now is to see if we can't establish some common sequences, come up with the formulas for some common sequences. And here's what we're going to do. I think this will be fun. I think I'm going to go around the room and ask people. Yeah, let's do that again. That's fun. Our definitions of fun are different? Okay, well, this is fun for me. And I think it's fun for you too. You act like it's not. Okay, so everyone ready? I'm going to put you on the spot today. Okay. Now, if we're going to play this game right, that means no one can be blurting out the answer if you know it. Okay? Give everybody a chance. Here we go. Here we go. I'm going to give you the sequence.
These are infinite, right? You're not doing finite.
Is that infinite or not?
That's infinite.
That's infinite. Okay, so what I'd like is for somebody to tell me the formula for this.
Would it just be n?
Yeah, that's all it is, right?
Yeah.
Okay. You got the easiest first one. I picked. I'm just going to go around the room.
Oh, yo, scratch my navel.
Okay? I'm going to go like this through the room. That's what I'm going to do. You ready? Now, these are going to get harder, and I'm not going to expect that people are going to be able to get them right away. Okay? But does everyone understand why this is n? Okay. All right. Next one. No one blurting out the answer, or you're disqualified. Any, many, miny, mo. No, here. We'll go here.
2n.
2n. Do you all agree? This is actually a special one. Because you plug in 1, right? You plug in 1, you get 2. You plug in 2, you get 4, 3. So this generates the even numbers, doesn't it? Yes? You're up. No help, no help. I'll help you out here. There you go. Okay, let's go with that. Can you use the same thing? All right, so start now with 1, and what would you get? Plug in 1 here, what do you get? You get 2, right? You don't want that though, right?
No, I want 0.
So how could you make that 0 instead of 2? It's a simple thing. Don't overthink it. If you plug in 1, you get 2, right? But you want 0. So what would you need to do to turn your 2 into a 0? Minus 2, right? So think about it this way. If you look at this, if this sequence right here, that formula generates this list is just that list, but take 2 away from each one, right? So your formula, if you take 2 away from each one, you're going to just basically shift. It's like you're shifting this entire sequence back 2. That make sense? Sure? So let's just double check it. We plug in 1, we get 0. We plug in 2, we get 4 minus 2, that's 2. Plug in 3, we get 6 minus 2, that's 4. Got it? Okay. Go ahead, since you seem very into it here.
Okay, wait, can I write it down?
Yep. That means this side's going to get the hard one, the real hard ones.
Or, sorry, wait.
What? Okay, yeah. No, it's okay. Are these all even numbers still? Do they keep jumping by 2 each time? Do they? They do, right? So I should still be able to use 2n because that creates even numbers. Minus 6. That will take you and shift you all the way back to where you need to start from. Does this make sense?
Yeah.
Okay. So basically, we can do this for any list of even numbers. We could, let's say, you said 2n, I agree. Plus 8. Plus 8. 2n plus 8. Are we good with this? Sure. Oh, wow. All right. Go ahead. Do you recognize those numbers? Those are your odds, right? Do they go up by 2 each time? Right? And the formula we use to make things jump by 2 each time is this formula, right? But it's not this list, right? Do you recognize a relationship between this list and this list? Like instead of getting 2, there you go, 2n minus 1. 2n minus 1, right? It's everything, it's the even list right here. Take 1 away from each one, and you'll be odd, right? All right, so how about if we wanted to start off like negative 1, 1, 3, 5, 7. Hold on. What do you got?
So it's going to be 2n minus 2.
Not 2. If you plug in 1 here, you get 2, right? But you want to be at negative 1.
So minus 3.
Minus 3. There we go. All right, moving along to the next table. Moving along to the next table.
So will this be something
What?
like an easy thing to be tested on? You'll give us a sequence and tell us what it is.
And ask you for the, yeah.
So this is going to test.
It's not going to be this easy.
Well,
Like a more
Yeah.
complicated version.
Yes, you'll see how it's going to be.
Sequence.
I probably won't give you a sequence. We're going to have to find sequences. This will appear at some point, but it won't be like, here's the sequence to give me the formula. Like, this is going to happen in the problem, but it's not just, like, this is not the only part of the problem.
Yeah.
So this is only part of the problem.
This is going to be only part of the problem, us coming up with a formula.
So the other part of the problem is finding the sequence.
Yes, exactly. Like, we will figure the numbers out, and then we'll be like, oh, okay, what's the formula for that?
So like for example, so like there's gonna be like numbers missing, and we have to find those numbers for the sequence and then find the formula.
Basically, we have to find the numbers of the sequence and then find the formula for the sequence. All right, here we go. You ready? This one's going to be a little bit tougher, okay? Sorry, hold on.
Okay, so the first thing I notice is they're going up by 5 each time.
Yes, they are going up by 5 each time.
So I think I would start with
Yep, I agree.
and then -2.
Perfect. That's it. Okay, so I think you're getting it. The jump that each one, in all of these problems, there was a common jump, right? 2n, 2n, and then we just had to like tweak it to make it fit where we wanted. Here, the common jump here is 5, 5, 5, right, each time? And because of that, we know that we can use 5n. The question becomes, where do we start it? So if we plug in 1, we get 5, but we want it to be 3, so we subtract 2. Now if we plug in 2, we're going to be at 10, minus 2 will be 8. Okay? Good, good, good. You ready? Who's up? Okay. I'll give you a hint that this one is different. It is different. You don't have a common jump anymore, do you? Like it goes up 2, then it goes up 4, then goes up 8. What? Okay. You said this one is 2 times 2?
Yeah.
So can I write that as 2 squared?
Yeah.
And this one is 2 to the third, and this one is 2 to the fourth, and that first one was 2 to the first, right? 2 to the n. 2 raised to the n. 2 raised to the n. There's a difference between 2 times n and 2 raised to the n, right? Okay. Good. Ready? Okay, we're still going around the room, so don't worry, you will get your chance. Do you see any patterns that you recognize right now? What about them? Exponential? How? Okay, so how are these all related to one another? I want something, give me more. What can you? One third to the n? Is that what you mean instead? I think you're trying to cut off too much at one time. Let's find a pattern. 9, 3, 9, and 27 are all related in what way? Like what's the connection? Like over here. Look what I did to try and help us see the pattern here. How could I rewrite those to see a pattern? This is 3 to the first power, right? This is 3 to the second power. This is 3 to the third power. Agreed? Everyone agree? So let me write this one. This one is 3 to the first power. So here's what I've got. I've got 1 comma 1 over 3 to the first, 1 over 3 squared, 1 over 3 cubed, dot, 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 right? Right? So since all the numerators are 1, including that one, right, is 1, I could just put 1 up here, and then what could I put on the bottom? 3 to the n. Okay, let's look at this, everyone. Will that work? That's close, but the problem is if you start with 1, you get 1/3, then 1 over 3 squared, right? Then, so you're missing this one, aren't you? You're missing this one. You need that when you plug in 1, you get 1. Minus 1/3? Like minus out here? No? Oh, minus 1/3 here. That won't work. And where, what, minus what? Oh, minus 1 here. Wait a minute, minus 1 right there? Oh yeah, look. That's really 1 over 3 to the 0. Because what's 3 to the 0? What's anything to the 0? 1. We have to see that in this pattern. Y'all see that? That formula will work. If we plug in 1 now, we get 0 here. 3 to the 0 is 1. Then we get 1 over 1. So we get our first one. Make sense? Does that make sense? Okay. All right. I'm not going to go too much, I guess. I'll keep it relatively within the same ballpark here. I don't know. What do y'all want? Anyone? Yeah, go ahead. Go ahead.
On the first try.
I'll always help y'all out. I'll always get that there for you. There you go. I'll get you halfway. That's actually more than halfway because I've got this and that. So all you gotta do is this. Do you see the same pattern that we had in the previous problem? Do you see that that's 3 to the first, 3 squared, 3 cubed? So we still have that. Let me see. And then this one over here is really 1 over 3 to the 0, right? This is 1 over 3 to the first, and then 1 over 3 squared, and then this is 1 over 3 cubed, yeah? So that first one, 3, if it's gonna follow this pattern, right? Then this one would have to be 1 over 3 to the negative 1, right? Is it? Yes, 1 over 3 to the negative 1 is really 3 to the positive 1 because you would push that up, right? Which is 3. Does that make sense? Yes. Okay, so your formula then needs to look exactly like this, but with one little tweak to it. Minus 2. 1 over 3 to the n minus 2. Now if you start at 1, you get negative 1, and then when you plug in 2, you get 0, and then when you plug in 3. Yeah? All right. You ready? Here we go. Oh, wait, hold on a second. Just want to double check this real quick. Got to make sure it works the way I want it to. Why am I missing? This was supposed to be negative 1, 1, and then we'll do one more. Can I give you some advice?
Is it 2/4 n minus 1?
2/4 and to the n minus 1? I don't think it is. I should also mention that the formulas you come up with are not unique. Someone else could have a formula that looks different and creates the same sequence. So sequence formulas are strange in the fact that there's several ways to represent them. Okay, let me give you some advice first. Whenever I see fractions, I always try and separate the numerator and denominator and try and treat them as their own sequences. So when you look at the numerator, do you see anything going on in the numerator? Do you see, hold on. Do you see anything going on in the numerator that you see a pattern in? Just the numerator.
That is going by adding 2.
You're adding 2 each time, right? So that's basically like 2n. So why don't we start with that? This is like 2n on top, right? Now, if I plug in 1, I'm not going to get -3. So what would you have to do to get it to start at -3?
Minus 3,
Oh, almost?
minus 4.
Nope. Plug in. What happens when you plug in 1 right here? You get 2, right? But you want to be here. -5. Okay. So let's just check that. If we plug in 1, we get -3. If we plug in 2, what do we get? 4, take away 5. We get -1, right? Plug in 3, we get 6 minus 5, that's 1. Right? So that's going to work. So we got the numerator covered. Now, look at the denominator. Do you notice anything in the denominator? It's 4, right? These are all powers of 4. This is 4 to the first power, 4 squared, 4 cubed, 4 to the fourth. Agreed? So the first one starts at 1, right? So what could I do for the bottom? Just like we did with these. 4 to the n. 4 to the n. 4 raised to the n. Do you all agree that that would do it? Yes?
So when it's a fraction like that, you can look at.
I like to look at fractions separately, top and bottom. That's the way I like to look at them. And I hope to find patterns that way. All right, next one. Now I'm going to put a star next to this one because this one's really important. Anybody at this table want this one?
Sure.
What do you got? -1, 1, -1, 1, -1, 1. I forgot to help you. There we go. When you plug in 1, you want -1. When you plug in 2, you want 1. When you plug in 3, you want -1. When you plug in 4, you want 1.
N minus 2n.
It's not jumping by the same amount, right? I mean, it's like, well, I guess you could, but it's jumping up by 2, down by 2, up by 2. So you can't use 2n to make it do that. What is the very nice property of the number -1? If you take the number -1 and raise it to powers, what happens? Depends on what you're raising it to, right?
Oh, 1 to the n.
-1 to the n. -1 to the n. Now let's think about this. If we plug in 1 here, what happens? We get -1, right? We plug in 2, we get 1. And we plug in 3, it's an odd power, so you're going to get a negative again, right? This right here is very important, everyone. I started already. This is called an alternating series. Sequence. An alternating sequence. Because it alternates in sign. It goes from negative to positive, negative. Was this alternating? No, it did not switch negative, positive, negative, positive, negative, positive, right? Whenever it switches like that, it's called an alternating sequence. And we will need that and use that quite a bit. So this whole thing right here would make it alternate, right? So with that said, I'm going to ask a different question this time. Who wants? You want it? Okay, so I'm going to ask a different question. I want to know this. Can you tell me what sequence this would generate?
And it just be, they would start off like positive.
Just plug in one for yourself. Just plug one in here. What would happen if you plug one in?
That'd be negative 1, 2, third,
Okay, which would be
negative
-1. Okay, now plug in 2.
-1 to the fourth.
Okay, which would be 1. And then same thing, right? Isn't that exactly the same thing? Isn't this the same as this? Well, what I'm trying to get you to see is that if you take -1 and raise it to the n, you're going to get this sequence, right? But if you do n plus 2, you're going to get the same sequence. If you do n plus 4, you get the same sequence. N plus 6, you get the same sequence. Understand? Okay. So there are an infinite number of ways to represent this sequence. Just depends. So this is the standard one that we use. Okay. All right, next one, moving on.
The way an antiderivative is like a family of functions, is that the same as this?
With that one, it's just a result of the fact that's just a property of this -1, that if you do -1 to the n plus any even number, you're going to get the same sequence. It's not really like a family, so to speak, because it's not any constant. If you do n plus 3, it's not the same. It's only even. All right, go ahead. There you go. This is it. All right, so this one is another important one that you should know. This is an alternating sequence, right? The difference between those two is that this one starts positive, right? And that one starts negative. If you want to create your sequence, or you ever have a sequence that starts positive, then negative, positive, then negative, then you use this instead. Because when you plug in 1, you actually start at 2, right? And that'll give you that one. And when you plug in 2, you're at 3. So you're at this one, and then so on and so forth. All right? Okay. How are we doing on time? Man, it's all gone. All right, this might be the last one for these. Let's see, 5. Well, let's just go 5. Then let's go 9, -9 halves. And then 13 fourths. And then -17 eighths, ... You ready, Hugo? It's not as bad as it looks. Yes.
So the denominator is going to be
Yes.
2
Yes.
and
Yes.
minus 1.
Good. Okay. The denominator is 2 to the n minus 1. So you're recognizing that this is really down here 2 to the 0. 2 to the 1, 2 squared, 2 cubed. I agree. 2 cubed. I agree.
And the numerator is oh, it's different.
So I think what might be throwing you off is this is minus, right? Okay, so I want you to completely separate. This is alternating, isn't it? Okay, so ignore the signs because you can make this alternate with a formula. So if you're just looking at the numbers without the signs, could you make 5, 9, 13, 17 for me?
Yeah.
How?
Setting 4.
Okay, so what's the formula? You just told me it jumps by 4 each time, right? If I ignore the signs? So what?
So 5 and plus 1.
4n.
Or 4.
4n. 4n plus what?
Plus 1.
Plus 1. Does everyone agree that that would create the sequence 5, 9, 13, 17? Right? But it doesn't take care of the alternating. So to do the alternating, just out here on the side, how do we make it alternate starting positive then negative, positive then negative? To the n plus 1, right? This one creates this, right? So if I put negative 1 to the n plus 1 out here on the side, then I will create that sequence. Make sense? This will be 5. When we plug in 1, we get 5 over 2 to the 0. And it will be, plugging 1 in here, squared, so that'll be a positive. So it'll be positive 5 over 2 to the 0. When we plug in 2, we get 8 plus 1, that's 9, over 2 to the first power, so that's 9 over 2. But then when we plug in 2 here, we get a 3, so that makes negative, and that gives us the negative sign. And so on and so forth. Make sense? Okay. All right, the last thing, and I know I'm almost out of time here. I just need to introduce you to the notation. Well, you know what? There's no sense in me doing it. We don't have enough time. So why don't I just put one more on the board? And since I have 4 minutes, let me see if I can. Can somebody turn on the lights real quick? On. And bottom left off button on the projector. Who'd I skip? I skipped you? Oh, I'm sorry.
That was supposed to be his.
Yeah.
That was not fair, son.
It was not intentional.
You just skipped everybody. Just went straight to me.
It was not intentional. I really thought we were done over here.
You could just give him the hard one. You're going to get him.
Yeah, you need to make it good.
I had a question where you just want to drop it.
Oops.
What problem?
Not too bad. Just treat top and bottom.
Yeah, that's what you do it.
Yeah, and then you put that to the side.
Like the bottom?
Yeah.
Yeah, but remember we were talking about sequences that can't start with 0?
No, the output is 0, 0, 0, 0. We need n minus n.
I like that. Yeah, that's true.
That'd be legit.
Almost done.
He's making it special just for you.
No, this is going to be for everyone.
Oh.
Take home quiz of sequences. On top of what we got.
Our quizzes are due next time.
Mm-hmm. Yep.
Bonus points if you turn them in early.
Nope.
Can we ask you questions on it?
You can ask. What the heck, man? What is going on here? My program is acting very funny here.
Save your McAfee special.
There it goes. All right, you ready? Here it is. This is a take-home, just a little fun problem. 144, negative 12. Negative 3. (9/4). Oh, wait, hold on a second. I might have missed okay, it was 144, negative 12, negative 3. Yeah, that's right. 9/4. Negative 15 over 16. I'm going to give you quite a few because the more I give you, the easier it'll be to get the pattern here. (21 over 64). Negative 27 over 256. Dot, dot, dot. Okay.
Is this great?
Pardon?
Is this a grade?
I'm giving you a problem. Do what you want with it. Yeah.
I guess on the no side, I can make it pretty or not.
Yeah.
Or I might just do it before, you know what I mean?
Yeah.
That's what that's gonna be. Same, bring it in on paper.
I'm giving you a problem if you'd like to work on it. Yes. Yep. 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 Yes. I do.